Hello everyone. I'm just moving on to question 3 in review exercise 3.4. The first two questions were all about using a standard normally distributed random variable, either finding the probability of a certain of z being in a certain region, or given the probability, how big is that region? Now in question 3 we're going to learn how, we're going to take the second step. We took the first step by figuring out how to work with the standard normal distribution, but the second step is all about how to work with a number or a just regular normally distributed random variable, right? So x is a normally, as opposed to standard normally distributed. It's normally distributed. And the big difference here is that now when you draw this, your mu, the center, the midpoint of your distribution is going to be not 0 anymore. It's 1.35. And in fact, this curve itself looks a lot different than this curve. Now, because I can't draw perfectly precise mathematical drawings, they're always going to look different. But typically the shape of this thing, like how high it is, how wide it is decided by this number right here, which is the standard deviation. And that's going to play in here. Now, there's a cool fact about this, is that because it's all normal distributions, they're all symmetric and everything like that, as you can read in your textbook or in your manual, the probability that x is bigger than that number right there is actually exactly equal to the probability that some normally distributed random variable z is bigger than some other value z1. And the way that you have to convert these, what you have to do is you want to turn this 0.82 into a z value that corresponds to it. And then by figuring out the probability of the z value, it can then immediately, it gives you the answer to the x value as well. And the way to do that is using your z-score formula. So if I were to look for it on my formula sheet, and your formula sheet as well, it would be this one right here. Okay, so z equals x minus mu over sigma. Or in this case, if we call this x1, and I'm just giving them a number so that we don't confuse this z with this z, and this z varies, and this x with this x. So this would be z1 equals x1 minus mu over sigma. So we plug those numbers in, and it's gonna let us take this problem, which is a problem on a normally distributed random variable, and consider it as a problem with a standard normal distribution. And the reason we're doing that, the whole point of doing that, is that this table, you read what it says here? Standard normal distribution. If that weren't the case, I'd have to have a new table for every single value of mu and every single value of sigma. But, you know, I don't want to have to juggle through like hundreds of different tables. So what we do is we just convert our x values that were given to z values and then work with them from there, which we already know how to do from question 1 and 2. So let's go through this. So we need to find this z1 that is going to let us figure out this probability. And notice that it's the exact same, right? The x gets replaced with a z, and the number value gets replaced with a value we're going to figure out. So z1 equals x1 minus mu over sigma. And let's just continue. I'm just going to plug these values in. x1 is going to be 0.82, as is given in the problem, minus mu, which is 1.35. And don't worry if these numbers are negative sometimes. That's just sometimes just the way it goes. And I think it might be negative in this case. And then that's going to be divided by 0.65. And what I get when I compute the number on my calculator, 0.82 minus 1.35 divided by 0.65. And I get 0.815. And you know, because you're working on a standard normal distribution, because you're going to be using only values that have 2 decimal places, you only really need to round to 2 decimal places in this case, in just this specific case. Usually we don't want to round until the very end, but when it comes to this stuff, it's okay. All right, so Z1 is 0.81. So what we're saying now is that we need to find the probability that Z is greater than, oh, and sorry, this should be negative. My apologies. This should definitely be negative. You see, even on my calculator, it says negative. So we have negative 0.81. And if we remember correctly, if we were to draw this out, remember, this is just equal to, sorry about that. Let's just make sure we're doing this the right way. Yeah, okay, so this is going to be equal to the probability that this is larger than this number. And in fact, that kind of makes sense because if this is 0.82, as is given in the problem, and we're trying to find this whole region up here. Well, the nice thing is this side right here is 0.5, just automatically, because that's the whole half of the graph. And that's always 0.5. So we really just need to figure out this is equal to 0.5 plus the probability of this region in here. So we just have to take this, which is 0.5, and add it to the probability in here. So this is the probability that negative 0.81 is less than Z is less than 0. But this is nice because, again, anytime we're based around the 0, we can just look on our handy table for 0.81. So 0.81, 0.8, and 1.2910. So this is equal to 0.5 plus 0.2910. That should probably be in blue. Whatever the case, this equals 0.7910. So ultimately, because the probability that x is greater than 0.82 is equal to the probability that z is bigger than negative 0.81, and this actually, we just figured it out, was equal to 0.7910. And that gives us the probability here. So as I'm writing up the next question, I'm just going to kind of talk about the use of this. Eventually, if you look on the same page, and I think what I'm going to do is I'm going to be posting the page in the link on just underneath the video, and just so that if you happen to not be from Stat 202, the class that I'm teaching for this, but you still want to learn a little bit more about how to do these problems, you can see where I'm taking these problems from. But if you go to question 5 in the review exercise, we're trying to figure out the probability that an age of person arrested for some offense is between some bounds. Well, the way you model that question is actually with these probability that x is greater than 0.82, or using x, using a normally distributed random variable x. And so this is that second step that you're going to need to knowing how to do these normally distributed random variable word problems, which for those of you in my class, you have an assignment on. So the probability, maybe I'll post that assignment in the link too, just in case. So probably 1.32 is less than x is less than 2.76. Okay, so same deal. This is going to be equal to the probability that z is between Z1 and Z2, where we don't know what they are, but we're going to be able to figure them out. So, and this time I'm just going to wait to write out a graph so that I don't need to graph it right away. I'm just going to do the conversion immediately. So the first step here, whenever you're trying to figure out the probability of an x value and you need to convert to z value, is just to do this conversion. So Z1 equals 1.32, and I'm just going back to this formula, just saving myself a little bit of time, not having to write it out, minus 1.35 divided by sigma, 0.65. And Z2 equals 1.32 minus, not 1.32, my bad, that's 2.76 minus 1.35 divided by 0.65. So Z1 equals, I'm just going to figure that out, 1.32 minus 1.35 divided by 0.65, and this gives me negative 0.76. And I'm just rounding that off again because whenever it comes to z-scores, I only need 2 decimal places. Z2, this is 2.76 minus 1.35 divided by 0.65, and this is going to give me 2.17. Okay, so what we're doing is we're trying to figure out the probability that z is between negative 0.76 and 2.17. So if I were to graph this, and you can save the graphing until you get the z values here, just so you don't have to duplicate your efforts. If this is negative 0.76, and this is positive 2.17, you're trying to find this whole region in here. Okay, so actually what you're trying to figure out is this region down here, again, because everything has to be based off the z, or the y-axis, the 0, and the probability that we're in there. So let's just go ahead and write that out. This is equal to the probability that z is, oops, I'll make that negative, z is between 0.76 negative and 0 plus the probability that z is between 0 and 2.17. Okay. All right, so now from here, I'm just going to plug these values in. We can look this all up on the table. 0.76, so 0.76, where's that going to be? 0.7, and then go over to 6, 0.2764. So that's equal to 0.2764 plus, now this one, 2.17, 2.1, and then 7 right here. 2.17, 0.4850. Okay, add those two values up. 0.2764 plus 0.4850. This is going to give me 0.7614. And so then, again, because this directly converts to this, what I can say, and I start skipping steps as I go along, just because you can always backtrack in my videos and see me take all the steps, but I'm just going to not write out this extra little bit that I did last time because I think it's clear from before. 2.76. So I'm just going to you're just going to have to understand that this is equal to this, and this one is the same as this. So then this this probability right here happens to be equal to, because we figured out what the value here was, 0.7614. I'm just going to go ahead and circle that because it's always nice to highlight our answer. It makes it wonderful for the people marking. Okay, I'm going to flip my page. Whoa, this is page 5 of all this stuff I've been doing. I've just been trying to keep track of all these things so that maybe eventually I can put the notes up so that you can kind of go back and look at them. So 3.4, review, and this would be page 6, unless I happen to make some sort of an error. So this is C. Well, here we're trying to figure out the probability that x is less than 2.54. Okay, so again, we follow the exact same procedure. We know that this is the same as the probability that x is less than z1, or sorry, z, my apologies. And now we just have to figure out what z1 is going to be. z1 equals 2.54 minus, remember that in this case, mu was equal to 1.35. This was given to us in the problem, just to remind you. And sigma was equal to 0.65. And remember, I'm using the formula z equals x minus mu over sigma. Okay, and that's where I'm getting these values. X goes right here, mu goes right here, 1.35, and then down at the bottom we have our standard standard deviations, 0.65. What am I getting? 2.54 minus 1.35. I'm going to get 1.19 divided by 0.65. This gives me 1.83. Remembering just to round to 2 decimal places because that's all we need to make the standard normal distribution chart work. Okay, so now we're saying the probability that z is less than 1.83. Okay, this is what I'm now trying to figure out. So I'm going to draw it. Okay, so this is 1.83. This is a 0, and I'm trying to find all this region in here because, again, I'm saying z is less than this number. Okay, so we know that this little region in here is 0.5, just automatically. So this is equal to 0.5 plus the probability that 0 is less than z, which is less than 1.85, or 0, or z is between 0 and 1.83. I pull up my chart, 1.8, and then a 3 over here, 0.4664. So this is equal to 0.5 plus 0.4664. Okay, just to see that again, 1.83, just the replay, 0.4664. So this is equal to 0.9664, and we rewrite this, the probability that x is less than 2.54 is equal to 0.9664. Okay. Let's do question D, and this will be the last one because that's the last one in question 3. This is the probability that negative 0.22 is less than x is less than 0.04. Okay, same deal. This is equal to the probability that z1 is less than z is less than z2, or that z's between those two values. And then again, we use this formula up here. We have over here z1 equals, and now we put the lower x, so this is negative 0.22 minus 1.35. Remember, because we're x minus the mean, the population mean, 1.35 divided by the standard deviation, 0.65. Sorry for saying so much, or you know, anything akin to that. It's kind of tricky sometimes. You feel like you need to fill up that extra space while you're writing stuff out. No need, no need. It can't make stats more exciting. It's already exciting enough. So we have 0.22, and it's a negative number, minus 1.35. I'm going to divide that by 0.65, and I get negative 2.42. Then for Z2, we have, this again, 0.04 minus 1.35 divided by 0.65, and I get negative 2.02. So now, then let's make the conversion, and then I'll show you what we're working with here. 2.42 is less than z, is less than negative 2.02. So if I were to graph this, as I try to do for every one of them, and I draw my little hump here, this is negative 2.42 right here, and this is, negative 2.02. Then down here we have negative 2.42. It's this little region in here, because it's sandwiched between the two of them, so I shade in the region between negative 2.42 and negative 2.02. Okay, so remember, the way we figure this one out is we take everything up to here and we subtract off, you know what, let's use purple for once, everything in here, right? So this part gets subtracted because, again, just think about it geometrically. If you figure out the area, or the, you know, the probability, which for me, I think about it in terms of shading. If I figure out from here to here, that shades the whole region in. Okay? But then I say, oh, but wait, if I want to find the final answer, I need to subtract off this little bit down here. Well, that's what I'm going to do. So this is equal to the probability, put the equal sign there, and I'll try to color code it as always. Negative 2.42, or z is between negative 2.42 and 0, where my red region is, minus, because I need to take it away to get the leftover, the probability that what is this? Negative 2.02 is less than z is less than 0. So it's kind of converting that math into geometry and vice versa. So now this one, 2.42, let's look on our chart. 2.4 and then put a 2 here, there's 0.4922. So this is equal to 0.4922 minus, and now we look over here, negative 2.02, 2.02, which is 4783. And what do we get as a final answer? Get that calculator out. 0.4922 minus 0.4783. And I get, this is equal to 0.0139. So remember, just going back to this is equal to the original problem. So if I write it out, the probability that negative 0.22, that x is between negative 0.22 and 0.04, this is equal to 0.0139. Okay, and that's it for question 3. I'm going to try to get question 4 up as soon as I can. And yeah, so, and also just I'll just reiterate, I'm going to try to put up the review exercise just down in the comments there. So, okay, thanks everybody. See you later.